Students, Miss Mason here. Hope you're working on your dance moves. Some transform sliding going on and some convergent crashing and some divergent diving. Remember, dance moves, work on them, post your dance moves or your dance that you created inspired by the plate boundaries. Woo! Brutus likes this. Post it on Seesaw by Friday. Winner is exempt from one assignment. One. But that's a big prize, so please participate. It'll be fun. Okay, today I just want to review a few things about the boundaries. We talked about convergent boundaries coming together, and if I said they're crashing, right? Can form mountain ranges. So if two continental plates, or two plates that have continents on them, crash, it can form mountain ranges like the Himalayas. On the other hand, if one is a continent and one is an oceanic plate, and they come together, the oceanic plate will subduct underneath the continental plate. It's a little thinner, right? The crust is thinner. It'll subduct, so it goes down. And when it does that, it can form trenches. So trenches can be formed from this. It can also form volcanoes. So what happens is, this is going to be the oceanic crust, this is the continental crust. Come together. Oceanic crust goes underneath the continental crust. Remember, the oceanic crust is where the ocean is. It has water. So that water spills out into the mantle. And when the water spills into the mantle, what it does, it actually lowers the melting point of the mantle. So the mantle, which is like silly putty normally, it'll actually melt and become liquid-like. And that is called magma. So liquefied mantle is magma. So magma forms down there. And that magma is liquid. So it's less dense than the solid mantle. So it rises to the top. And it goes up and up and up. And it creates pressure. And eventually it cracks through the surface of the earth in the form of volcanoes or volcanic eruptions. And then when that magma is above the surface of the earth, it is called lava. So magma and lava are the same thing, it's just the location that gives them the name. So if it's a liquefied mantle underneath the crust, it's called magma. If it comes out of the volcano, it's on the surface of the earth, on this crust, it's called lava. Hello students, this is Miss Mason here. I just wanted to talk a little about earthquakes. So here we have a picture of a fault line. So a fault line is a line where two transform plates come together. Alright, so transform plates, remember, slide next to each other. So wherever they interact, that's the line that is a fault line. Now, if we zoom in on, let's say, the San Andreas fault line, it could look like this. So this side would be the Pacific plate, and this side would be the North American plate. And when they slide, so imagine them sliding, and in fact the North American plate is going south and the Pacific plate is going north. So this is going up and that one's going that way. When they do that, if you can imagine, since we're zooming in, you can see these all interlocking parts. So the rocks are not completely flat. Alright, so they don't easily just slide along. Alright, so sometimes it creates friction when they move. And sometimes they get stuck. So if they slide and they get stuck, it creates a lot of pressure, and that pressure buildup causes the shaking, is released in the form of the earth shake, earthquake. All right, so when they get trapped and they can't slide freely, that's what causes earthquakes. All right, so a fault line, or just a fault, is the line between two transform boundaries. And San Andreas Fault, you can obviously see when you go to Google Earth and you look at it. It's very large, very easy to see, and that is where a lot of earthquakes will happen because the plates are sliding, but they're not perfectly flat. So if you zoomed in on those plates, those surfaces are not completely smooth. They look something like this. And this is a problem when they're sliding because they can get trapped. All right, so it's not just like this. It's not like this. This would be easy to slide. It's more like this. And when it's like this, here, it either gets stuck. So if they got stuck and they need to slide right here, it's going to create a lot of pressure. A lot of pressure that builds up and creates the earth to shake, creates the shakes, and the ground, the crust, shakes because of that, because it gets trapped. He got nervous because he thought we were experiencing a real earthquake. Okay, anyways, so if you think about a door, let's say you're trying to get into class and the door's stuck. It's not locked, but it's just stuck, it's jammed. So you're trying to push it, but it doesn't go. You push again, it doesn't go. Push again, it doesn't go. Push harder, and then the door pushes open, and you go in. If you go flying in, maybe fall because you're putting so much energy into getting the door open. That's like with this. So if they get stuck and they're still trying to push, it builds up the pressure here, and that pressure buildup can lead to an earthquake. All right, because there's so much energy, so much pressure in there now because it's trying to move and it can't move. It has to release that pressure somehow, and it does so in the form of an earthquake. So that is just a summary of earthquakes.